All right, welcome to the Explainer. Today, we're going to jump straight into a tricky GCSE maths question. But here's the thing, we're not just going to solve it. Nope, we're going to build the perfect 4-mark answer, step by step, exactly how an examiner wants to see it. So, where's this from? We're looking at a higher tier paper. And get this, it's non-calculator. That means it's all about pure problem solving and really knowing your geometry. And here it is, our challenge for today. Question 17. This is a classic circle geometry problem, and it's worth a solid 4 marks. You can see it's got a bit of everything, tangents, ratios, and you just know there are some hidden angles in there. So, you might be wondering, how do we make sure we get every single one of those marks? Well, we're going to use the official mark scheme as our guide. It's basically the blueprint for a perfect answer. Okay, let's dive in. All right, let's get into it. The 4-mark challenge. What do we actually know? So, here are all the clues laid out for us. We've got points on a circle, there's a tangent, a 40-degree angle, and this interesting little ratio between 2 other angles. Our mission, find angle ACD. And, you'll see this is super important, we have to state the circle theorems we use. Let's start piecing this puzzle together. Okay, let's go for that first mark. What does our guide, the mark scheme, tell us to do first? Well, look at that. The mark scheme says the first method mark, that's M1, is for finding that angle BAC is 40 degrees. Simple as that. But why? How do we get there? It all comes down to a really cool circle theorem, the alternate segment theorem. You gotta love this one. It tells us that the angle between a tangent and a chord, right where they touch, is exactly the same as the angle in the alternate segment. And here's how it plays out in our problem. Since angle BCD is 40 degrees, that means angle BAC has to be 40 degrees too. Boom, just like that. We've got 1 mark in the bag. All right, on to the next step, finding the isosceles clues. Now we get to use that ratio information to lock in our second mark. Okay, checking the mark scheme again. It says the next mark is for finding one of these smaller angles inside our big 40-degree one. So let's break that angle BAC down. Okay, so we've got our 40-degree angle, BAC, and the question tells us it's split up, right? Angle OAB is 3 times the size of angle OAC. Think of it like a 3-to-1 ratio. So we're splitting 40 degrees into 4 equal parts. That means the smaller one, OAC, is just 1 part, so 10 degrees. And the bigger one, OAB, is the other 3 parts, which is 30 degrees. Easy enough. Now here is the real game changer. You have to spot this. Lines OA, OB, and OC, what are they? They're all radii of the circle, and that means they're all the same length. So what we've actually got here are 2 hidden isosceles triangles, OAC and OAB. And you know what that means for isosceles triangles, right? The base angles are equal. So this unlocks a bunch of other angles for us. Angle OCA must also be 10 degrees, and angle OBA has to be 30 degrees. And the mark scheme says that finding any one of those bags us our second mark. Awesome. 2 down, 2 to go. Right, putting it all together. We are so close now. Let's nail down that third mark. Now, the mark scheme actually gives a few ways to get here, but I think the clearest path is by finding the angle at the center, angle AOB. This is going to help us find angle ACB, which is a huge piece of the final puzzle. To do that, we need another one of the big hitter circle theorems. Remember this one? The angle at the center is twice the angle at the circumference. It's an absolute classic for a reason. So let's use it. Look at our triangle AOB. We know the 2 base angles are 30 degrees each. That's 60 total. Angles in a triangle add up to 180, right? So the angle at the center, AOB, has to be 120 degrees. And now, using our theorem, the angle at the circumference, ACB, must be half of that. So it's 60 degrees. And there it is. Our third mark is secured. Okay, this is it, the final step. Let's get the perfect answer and all 4 marks. You know, after all that work, the final calculation is actually pretty simple. The angle we're looking for, ACD, is just made up of 2 parts we already know. It's angle ACB, which we just found is 60 degrees, plus angle BCD, which they gave us at the start as 40 degrees. Add them together, and we get 100 degrees. So we're done, right? We've got 100. Well, not so fast. Take a close look at the mark scheme for that last mark. It's a C1 mark, which stands for communication. It's not just about getting the right number. It asks for something else. And honestly, This is probably the most important lesson for getting top marks in these kinds of questions. You absolutely have to state the theorems you used. The how you got the answer is just as important as the answer itself. You've got to show your work, show your reasoning. So, what does that mean for us? To lock in that final communication mark, you have to literally write down the names of the circle theorems you used. So in our case, that's the alternate segment theorem, and angle at the center is twice the angle at the circumference. You have to write them down to be safe. So let's do a quick recap of our 4-mark journey. First, we used the alternate segment theorem. Then we spotted those isosceles triangles to find the base angles. After that, we used the angle at the center theorem. And finally, and this is the crucial bit, we made sure to write down our reasons. That's how you build a perfect 4-mark answer.
So you see, the mark scheme isn't just for checking your answer at the end. It's a roadmap. It shows you the exact steps you need to take. If you use it to guide your thinking, you're not just hoping to stumble on the answer, you're building a solution that is guaranteed to score every single mark.